Hi guys, welcome to this brand new episode of the Clear to Send podcast. And we're back today with Arista to talk about network assurance. Last time in the previous episode, we kind of gave an overview of the entire Arista solution. And today we're back with some people from Arista to kind of do a deep dive on their network assurance and on their, I guess, AI as well. So today we have Roel here. Hey, Roel, how are you?
Hello.
Thank you for being here once again.
Yeah,
and then we have two people from Arista. We have Karan Gupta. How are you, Karan?
Hey, hi. I'm great. Thanks.
Do you want to present yourself for the audience?
Yeah. So, hi, this is Karan, and I'm a manager software engineering at Arista Networks, more specifically Arista Wi-Fi. And I've been working in the cognitive Wi-Fi space for a while now. And I'm also the one who created Packets, which is a free online tool to analyze packet traces. Right. So if not, just go to packets.arista.com and you'll find it there. So yeah, that's about me. Thanks.
I love this tool. I remember you talking about it, and yeah, it's really nice tool. It came from Mojo Networks, right? Back in the days, there used to be packets at Mojo Networks, right? And then it changed with the Arista. The name of the website changed.
Yeah, right. But it's still free for anyone to sign up. And yeah, the tagline there is a picture's worth 1,000 packets.
Right? Yes.
You check it out.
It's really nice. Yeah. And we have Robert back with us. Hey, Robert, how are you?
Good. I'm very good. Thank you. Yes, glad to be back. And for those that didn't catch the last podcast, my name is Robert Ferruolo. I'm a TME and I've been doing competitive testing, competitive analysis for over 15 years in the Wi-Fi space, and passionate about everything Wi-Fi, network optimization, and automation these days. Right. That's what I'm really looking at being a part of, helping automate, not to take anyone's jobs away, but just to help us, right? Have an assistance built in.
Well, that's the way it's going nowadays. So you don't have to take anyone's jobs away. Exactly. You can create jobs by making people work on the automation.
That's right.
See it that way. Yeah.
Make us focus on the things that matter.
Yeah, exactly. Well, thank you guys for being here with us today. And what we want to do today is talk about network assurance, how you guys do it, and talk about AI as well, because everyone is talking about AI. Everyone is putting AI into their marketing, into their product names nowadays, it seems. But AI is not, we don't really always get the same level of AIs, depending on the product we're getting. So maybe today you guys can kind of explain how you do AI in your solution. When do you use it? When does it make sense to use it? Can we trust the data that it's giving us, right, as a network operator? So maybe we can, talk about all of these topics today in today's show. So why don't, Karan, do you want to start by maybe presenting what network assurance means to Arista and what you guys do as part of the network insurance?
Sure, definitely. Let me share my screen.
Yeah, and just for people listening to the podcast, the audio only, we will have this also on video on our YouTube channel if you want to see what network assurance looks like. But we'll definitely talk about these points because I'm interested in network assurance and how we can be better Wi-Fi engineers and ensure things are working the way they should be working, right?
Right. So with that, so this part, right, where I'll essentially do a deep dive into give you behind the scenes look into what network assurance means to us and how we have solved that problem, right? So so network assurance actually starts with how the client experiences. That's why you want it, right? That's the why of essentially why we are doing all of the things that we're doing. And in there is this pyramid that you can say pyramid of needs for Wi-Fi clients. So first is connectivity, then comes performance, so connectivity experience, performance experience, and then right on top is your app experience. So it essentially goes from the deterministic nature goes becomes less, the whole thing becomes less deterministic as you go from bottom, from connectivity, from performance to app experience, right? So if you go from bottom to top, it essentially becomes less and less deterministic for the network to determine if the experience is great or not, right? So if we talk about connectivity, so we have something what we call as the client journey, right? So in case of client journey, essentially we show you that, okay, these many clients try to connect, and where all they kind of fell off, right? Was it association? Was it authentication? Was it at some network level? Did they get the IP address or not, and so on, right? Are the DNS queries getting resolved? So on. So the client journey kind of gives you this nice journey of how many clients are trying to connect and how many are not able to connect, and where they are falling off in this entire funnel, right? And finally, how many are online. So it's kind of very deterministic. You basically are monitoring the state machine, and what's going on, right, on the access points. So that is connectivity. It's a
I was going to say that would be considered like you said, it's very deterministic. So that would be considered the easy metrics to monitor, because you can just look at the frames, see if you see the authentication, the associations, and all of this, the DHCP request and so on, to kind of get that metrics into the cloud, I guess, for you guys.
Right. So it still means you are capturing a lot of data. You're sending every connection log back to the cloud, and you can do a lot more with that data itself. But from a connectivity perspective, it's deterministic, because you essentially have a state machine that on the access points that you can monitor and see what's going on, right? So that's connectivity part. Now the next part that we move to is performance, right? So for performance, we do have a performance dashboard where you can see what's happening right now. You can see the client health. Are some clients facing low data rate, high retry rate? Are some clients sticky or low RSI? How are the AAA, DHCP, DNS latencies, etc.? At the same time, you can see a baseline historically how your network is doing, right, on that same dashboard, right? So this dashboard gives you this overview of how your clients are doing across the board at present as well as historically, right? And you can drill down from here and get into a lot more details to see exactly what happened where. And you can also see where there were anomalous points. So on the screen here, we can see that on the baseline, you can see some red points which indicate that more than expected number of clients had an issue at that point in time, right? So so that's the anomaly detection part, which is really important in essentially someone being offhand instead of constantly having to monitor what's going on.
Would the red points or the anomalies change that baseline over time if you continually have those issues?
Yes, it would. So the baseline is also learning from the historical data. So if you continue to have the issue, the baseline itself would rise, right? But you can set an SLA, or you can set a threshold that if it goes above a certain percentage, then you need an alert, right, at that point in time. So it's actually a combination of automated anomaly detection plus some upper limit that the user can set to get an alert that things are kind of getting out of hand at this point in time.
Right. And how far back do you go into looking at the data to establish that baseline? Do you look at things like day of the weeks and things like that, or hour of the day to create that baseline?
Yeah, so we actually go back all the way to a month. So I'm showing here only a week worth of data, but you can see a baseline for an entire month. So the baseline is created using the entire month data, and you can see up and down based on how your network was doing over a period of time in that month, and you can actually drill down from each of these points here to see okay, which clients were affected and which were fine.
Yeah, and we didn't mention that again today, but all of these is part of the cloud dashboard that you guys have, right?
Yes. So this is I'm just taking some screenshots from the dashboard, which Robert will dive deeper into his session. Yeah. So so this is about performance, but let's talk about, so in terms of performance, right? I showed you client journey, but performance is slightly more tricky, right? So if you have a certain number of clients affected, right? Like there are 13 clients facing low data rate. Now that can be due to many reasons. And if you try and go into the details of each client, trying to figure out like what's the reason for each one of them, that's just going to take a lot of time, right? So how do you solve that problem, right? So that's where automated root cause analysis comes into picture, and I'm going to go a bit deeper into this, like how we do it, what is our thought process and approach here, right? And how it helps you reduce the time you have to spend on troubleshooting and understanding what's happening with your clients, right? So why do we need automated root cause analysis, right? So let's try to answer that question first. So when a client is facing an issue, right, there are two types of issues typically that the client can face. One is connectivity issues and other is performance issues. For connectivity issues, as we have already discussed, you can monitor the AP state machine, and essentially what you get is the client journey, right? Where you can see exactly where the client fell off. You can drill down, you can see what happened and kind of try to fix that. On the performance side, things are not that straightforward because it's not about a state machine. There are too many moving parts, a lot of dynamics in terms of performance. So it's not really a thing where you can monitor a state machine and deterministically determine what's going on. There can be multiple reasons at the same time, and different reasons might be impacting different clients, right? So that is where automated root cause analysis comes into picture. So Ava, which is our virtual assistant, is involved here in doing this root cause analysis. So how does Ava does this, right? So first is the symptom, which is what is the external facing symptom that the client is experiencing, like it's facing low data rate, right? So that's the symptom. That's like you're having fever, but you don't know why, right? Then there is observation, which is the list of clients with various parameters. We'll go into each deep into each of these topics. Then you have domain knowledge, how are different Wi-Fi parameters related to each other, and then you have system knowledge, like how is your system configured, what are the settings, SSID settings, and so on, right? And so those are the inputs to the AVA engine. And once you provide this input, right, you get the root cause analysis, which is essentially a report which contains what are the set of root causes that it has identified for the symptom, right? So if clients are facing low data rate, what are the possible root causes for that? And then a set of recommendations, what you can do to fix those issues. And finally, evidence. So evidence is really important because we were talking about trust, right? So how do you trust that what AVA has done is correct, right? So it needs to show you data that, okay, this is what, analysis I've done, and here is the data to quantify or justify that analysis or, the root cause inferencing.
Are you only looking at Wi-Fi data? Sorry, Rob.
Yeah, okay.
Can you elaborate on that? Like,
so are you only looking at? Yeah, I'm thinking. Are you only talking about like RF data, RSSI, and low data rates, and let's say layer 1, layer 2 information, or are you also looking at maybe what's happening on the wired network side as well?
Yeah, so we are building that into AVA right now as we speak, right? So okay. We are building that capability where it also takes into account what's happening on the wired side, right? Okay. But what we do is that when we are looking at application quality of experience, right, we at that point in time we kind of do some RCA that, okay, we are not able to figure out that Wi-Fi kind of looks okay, right? And then it might be an issue on the wired side, and we have a way to determine that, okay, is the issue in the downstream of that call, or is the issue on the upstream of that call, right? So if the issue is in the downstream of the call, it's likely on the wired side. So that's how we are able to say whether it's a wired issue or a wireless issue. to some extent.
I do like the visualization you provide here, because as you went through the connectivity issues and how we mentioned it's deterministic, this is exactly how I start troubleshooting, or how other Wi-Fi engineers start troubleshooting, right? They go and check, are you connected? What channel you're on? Like that kind of thing, right? Or making sure you get DHCP. And then once we clear that stage, then we start going into this part where we go, all right, like, is it a configuration thing? Is it RSSI? Like you're already doing all of this for us. So speeding up that process rather than trying to go and dig for that information.
Right, exactly. So so I talked about, like, in the screen that I showed earlier, I was talking about 13 clients, but in some cases you may have 300, you may have 100 clients, right? Then, I mean, how do you debug that, right? Like, how do you get to the bottom of the root cause? Like, there can be multiple issues at different locations. So that's the idea, like, making it easy, or for the network administrator to understand what's going on, essentially reducing the scope of how much they have to look around, right? Like reducing the scope of where they need to look and what they need to focus on primarily, right?
Do you do this for every client for every minute, or what what's the how often do you do all of these analysis?
Right. So this is right now in the product, it's on demand. So if you see an issue, you can actually say, okay, do root cause analysis for me at any given point in time. Right.
And you can go back, like, let's say, let's do it for the past 24 hours or something like
that. Not yet. So that's something we are also working on, where you can do root cause analysis on the past data. So this is about, like, if you see issue right now, then you can go there and do the root cause analysis. Yes.
Okay.
For client connectivity issues, though, you can go back in time, because for every connection attempt in the past month, if it fails, we do a packet capture, and we do an automatic root cause analysis for any connectivity attempt. But for performance issues, right, then that's real time.
Right.
You see in the future trying to trend performance issues over time? Because let's say, like even application performance issues, if there have been changes to an application, or somebody else's infrastructure or somebody else's app, you could try to capture that over time and be able to pinpoint, even with this, right, with the troubleshooting, be able to say this is something with the app. There's been a change, either a network change on the application side, or being able to see like an update to an app. So then you see this uptick in issues dramatically for some reason, right? Kind of similar to like connectivity issues. Like, do you see something like that being played into the future of Ava here?
Right. So so to clarify, we are still monitoring. So you can still see 1 month of data, right? And you can still see 1 month of anomalies that are getting detected. You can see 1 month of baseline. All of that is still in place, right? So if something changes in your apps, right? So on the application dashboards, which application quality of experience we are going to talk about after we talk about root cause analysis, there you can actually see how the apps are doing historically as well as in real time, right? So so that's already in place, where we are constantly monitoring, right? So what Ava does today is that if you see an issue like at that point in time and you want to troubleshoot it, and then you can do a root cause analysis at that point in time, right? But we are working on a version where you can actually look at historical data and do root cause analysis over time, right? And also we are working on something where if you see an anomaly, the root cause analysis is automatically done for you, like kind of taking us to the autonomous networking domain, right? So you don't even have to do it yourself. If the network sees an anomaly, it does the root cause analysis and takes the corrective action based on the recommendations that Ava has produced.
Can you implement these recommendations automatically, or do you still have it right now where the network operator will have like the last say?
Yeah. Yeah, so right now the network operator needs to implement them, whatever recommendations we make. The obvious next step is where the system itself makes picks one of the recommendation and applies that and sees how things are going. And then if that doesn't work out, then reverting back to the previous one or trying the other recommendation, right?
You can start doing some reinforcement learning and stuff like that.
Yes.
Yeah, an example of that might be you have what is perceived to be a coverage hold, perhaps, or something, and then maybe your max TX power on your APs is set below what this machine thinks would be optimal, and so maybe it would up that upper limit of TX power and see if that helps your KPIs, and so on.
Mm-hmm.
Right. So I think the key to this is that if you have a solid underlying or a solid root cause analysis engine, right, that's where things downstream become a lot better. If the recommendations coming out themselves are not really good, then applying them is of no point. So we have focused a lot on making AVA great in terms of producing root causing the issues and producing the right set of recommendations. We'll look at some samples of that as we go ahead. So as we move, let's look at what observations are. So observations are like at that point in time when you're doing root cause analysis, your observations are all the clients in the network, which may or may not be facing issues. And if you're doing a network level root cause analysis, that's essentially all the clients in the network. And if you're doing root cause analysis for a single client, then it's essentially all the parameters of that client, right, at that point in time or even historical, right? So the key point here is that you need a list of all the clients in the network, whether or not they are facing issues. That's really the key, so that you can correlate what's causing the issue, right? So for example, maybe all clients are facing some issue, then you cannot correlate, right? So you need to be able to correlate that only if you see this issue is when the data rate is low. So that correlation, to establish that correlation, you need a list of all the clients in the network, right? So it's not simply summing up or summarizing certain metrics. It's also about correlating intelligently how things are related to each other. Yeah.
And that's where the computer can help us, because doing this manually for us, that would be a huge work. We wouldn't do it, right? To be honest. Yeah. So that's where the computer can really work and help us. And I guess the goal here, Karan, is also maybe to kind of get an idea of the scope. Like, is that affecting everyone, or is the problem just affecting one client? Maybe you guys can use that for that.
Right. So from a scope perspective, right, if you're looking at all the clients, we have customers with tens of thousands of clients, right? So every time you do a root cause analysis on such a network, you are essentially looking at all of those clients to understand what is the issue with the clients that are affected, right? So it's a scale that obviously, like when you get to that tens of thousands of clients kind of a scale, it's beyond a human capability unless you kind of take the data and do it yourself somehow, right?
Yeah. So you do it for all of the clients. You don't only look at like one floor or one building or one room.
So it depends where you run the root cause analysis. So we allow you to run it at the root location. You can run it at a specific location within your network, right? So we have a location hierarchy where that's how things are arranged. Like depending on how you arrange it, you can arrange it like country, city, building, right, and so on. So you can run it anywhere you want. So you need to go to that location and you can run it. But you can even run it at the root location. And I'll show you a sample where it even says which locations are most impacted.
So you can just look at it holistically and be like, yeah, my whole Wi-Fi network is meeting my, the threshold the baseline that I want it to be at. But
yes,
most of us will probably drill down to a specific location and really compare that location to another building, for example, and try to troubleshoot and get things to a standard.
Right, yeah. So all metrics, all dashboards that I showed you, right? You can see them either at a holistic level, at certain aggregate level, like for example at a city level, or you can even look at that at a floor level. So it's up to you where you want to do the analysis, right? So yeah, so we were talking about observations. Next comes domain knowledge. So domain knowledge is essentially what we know about Wi-Fi and how different parameters are connected to each other. So for example, what can cause poor app experience? It can be caused by low data rate or high retry rate or high contention in the network, right? Now, if you go back from there, what can cause, for example, high retry rate? It can be low SNR or it can be high contention. If you go back from low SNR, it can be either low RSI or high interference, and so on, right? So there is this graph that that constitutes domain knowledge, and there can be other things related to client capability as well. Like for example, client doesn't support the latest 5 gigahertz protocol, or it. I mean, it's actually a 5 gigahertz capable client, but it's operating in 2.4 gigahertz, right? So it shouldn't be doing that. So it can be some things that related to client as well. So this is what constitutes a domain knowledge, and it is something that a Wi-Fi expert would know as part of their knowledge base, and that's the knowledge they would apply when they're debugging. So this is also built into AVA. When the analysis is done, this is actually taken into account, right?
So
how different things are related.
AVA is a CWNE at this point, right? This is an interesting slide because there's so much to Wi-Fi to really drill down to the root cause. So, and it will drive me crazy sometimes when I see a ticket and it just says the Wi-Fi isn't working, and I'm like, what do you mean? What about it? Like, and when you don't have this system in place, or even this process, right? Let's say you didn't have a system or an AVA to do all of this for you. This is kind of what you have to go through in order to troubleshoot. Like, is it low RSSI? Is it leading to the low data rate? What band are they on? Like, there's so much that you have to think about, go through, verify.
Yeah, I'm going to take a screenshot and show that to everyone who thinks Wi-Fi is easy.
Yeah, and this is not a exhaustive list of things anyway, right? Like, we know that.
You're right. Yeah.
Yes. So so this is a representative domain knowledge that's built into AVA when we do the analysis. Now let's talk about system knowledge, which is also equally important. This is essentially what is the state of your Wi-Fi system? How is it configured, right? Is auto transmit power turned on? Is dynamic channel selection turned on? Is 5 gigahertz actually being used or not, and so on, right? There can be other kind of meta parameters, which is like, how is your network topology? Like, what is the location tree looking like? How have you structured it? List of APs and their properties, right? What build they are on, and so on, right? So this is your system knowledge, and system knowledge obviously can vary from time to time based on how the administrator has configured. They may change the configuration. You may add APs, you may remove APs, or you may change how you structure your location tree, right? So this can change. So it can also impact the final analysis that's done, right? So all of this is also taken into account when doing the analysis, as well as when doing the recommendations, right? So if one of the recommendations is, you can turn on the auto transmit power, and if it's already on, we don't recommend it. So it's smart recommendation. It's not like dumb recommendation where we don't even go back into the system and see what's actually already configured, right? So that's where system knowledge becomes important.
And is this something that's configurable by the end user? Can I add something to this, or do you guys add things to this over time?
No, so this is the input that goes into AVA. So this is not configurable by the user, but we take into account all this data when the root cause analysis is run.
Yeah, I think that's critical because when I do like assessments for my customers, most of the time it works okay. But then there's a lot of things they could optimize to make it work even better, and I think that, if you know about Wi-Fi, but you don't know every little details about, all the settings you have in your system, that's some stuff you may overlook when you're just operating the network, and you have to take care of, the firewalls and the everything else, not just the Wi-Fi. So I think that's something maybe you guys can, can have an important part here is take a look at all of these optimizations that you don't necessarily, that are not necessarily obvious, but that you guys can recommend to the customer, saying like, maybe you should, in your case, you should do 5 gigahertz only SSID, or maybe you should use 20 instead of 40s, or all of these little details that sometimes are overlooked when you just deploy and use the default everywhere.
Right. Yeah. Right. So that's where the crowdsourcing bit comes handy, where you have a lot of customers in the cloud, you have a lot of data, and you can see what's working in what type of environments, and actually give recommendations to an individual customer to be able to configure their network better. Okay, so moving on, last but not the least is this symptom. So what is a symptom? It's important to understand that. So symptom is something like, okay, you're having a fever, right? And it's basically an external manifestation of failures, something that you can actually observe. It is things like, it's things like poor application experience, client is not facing great application experience, or it can be something like low data rate. And for us, the true metric is poor application experience, because there can be IoT devices that are sending frames at lower data rate by design because they want to conserve power or whatever, right? So you cannot always assume that low data rate means the client is not happy, right? And we have such devices in our campus where they by design send frames at lower data rate, right? So for us, the key thing is poor application experience, which we will talk about in upcoming slides. So anyway, so you define it as a symptom. So measuring that symptom effectively is really important before you can do the root cause analysis. And what the RCA engine or AVA is doing, or supposed to be doing, is you essentially say, okay, this is the symptom, and out of the many possible root causes, right, that domain knowledge graph that we saw where there were many possible root causes, which few, one or more, are responsible for this symptom? That is the key, right? Taking 10, 15 odd root causes, and basically reducing the scope to 1 or 2, and saying, okay, this is what's causing the symptom, you need to look into this, or these are the recommendations of how you can fix it, right?
Yeah, so I think it's critical in what you just explained is critical for the network engineer to trust the data coming from the AI, because like you said, you could have devices with low data rate just because they're outside, like at the skirt of the edge of the network, and that's totally normal. But you don't necessarily always want to tag these as problematic. So the fact that the AI is actually a bit more intelligent than that, and looking at other data source, trying to correlate all of that data to tell us if it's really an issue or not, I think that's critical in us trusting the AI. Personally, that's how I see it, because as network engineer, we've seen a lot of dashboards with a lot of alerts, and going through them, if you go through them, maybe 50% of them are not relevant because that's just normal in your environment. So I think leveraging the AI to really figure it out if it's normal or not in the environment, and if it's an issue or not, I think it's critical for the operator to trust the data.
Right. And I think false positives actually reduce the trust. Like if you see more and more false positives, right, that's what reduces that trust, and eventually you stop using a certain system.
Yeah.
Right. So that's the key, right? Essentially coming up with solid root cause analysis, which is supported by data as well at the end. Right. So symptom, and then I mean finally, like once you give all of these inputs to AVA, that's a lot of inputs, as you can look at it, right? Observations, domain knowledge, system knowledge, and obviously the symptom that the clients are facing. And then you get your root cause analysis report. And what are root causes, right? Let's maybe define that also, because we defined symptom. So if poor app experience is a symptom, root cause is something that's not caused, or are these are events that are not caused by other events, right? So for example, if the client might be facing poor app experience because of it's in a poor coverage area, right? There is nothing else that kind of causes poor coverage, right? I mean, basically you are away from the good coverage area, or away from the access points. So poor coverage kind of becomes your root cause, right? So root causes are things that you cannot further drill down. That is the reason why certain thing is happening. So as you can see here, like there can be multiple root causes, like there is Wi-Fi interference or non-Wi-Fi interference, too many BSSIDs or high channel utilization, or there are too many clients with high uplink traffic, right? So these are root causes that AVA can come up with once you run the root cause analysis, right? For symptoms such as poor app experience or low data rate. Right. So there can be additional quote root causes. These are not root causes, but there can be additional points that with which you can correlate, like, okay, this location is facing more issues, or this vendor is facing more issues, like client vendor, or this OS or this access point is observing more issues. So there can be such correlations as well, which you wouldn't call exactly root cause, but it can help you debug, okay, why is this AP facing more issues than other APs, or maybe a particular operating system or a particular type of client vendor might be correlated with the issues, right? Highly correlated as compared to other things. So these can also be indicated by AVA in the report, right?
So they can like guide you through your troubleshooting journey, pretty much.
Yes.
Okay.
You list the access point as an additional root cause. Could that be a way for you guys to check your own access point and make sure that, like, whatever the process is running on that access point, it's running properly? Like maybe some process needs to be restarted, or maybe
POE.
it's firmware, right? Yeah, POE firmware, like something that that needs an update to the AP. Like, can you determine that kind of root cause as well to help mitigate like bugs that we run into? Like, I know there's going to be bugs, like there's humans working on this thing, so it's gonna happen.
Yeah. So see, once you have, like, once AVA says that this access point is kind of correlated with these issues, right, then there can be multiple things, right? Access point not getting enough power, or the link speed is not good enough because of some cabling issue or something. So so that's where you kind of get into this wired analysis, which we are working on, right? But like the key point is, like, once you have identified the access point, there is enough data, you can drill down into the access point and see what's going on with that access point, right? What are the parameters of that access point that are kind of different from other access points, right? So yeah, that's where it so right now AVA kind of tells you, correlates the access point, but it doesn't really go into the details of what's different for that access point as compared to others.
Does AVA always find a root cause when you run a root cause analysis?
No. So unless it may not always find, right? So unless we are confident that this might be the issue, we don't show the root cause, right? So it may not always find a root cause.
Okay.
Yeah.
Are you still showing some data? Are you still saying, you might want to look at this parameter in more details, or are you just saying we didn't find anything?
Yeah, so the data is already there. So when you
Okay.
when you drill down from, let's say you're looking at a set of clients that are facing low data rates, and from there you can run AVA that tell me why. So at that point in time, we are already grouping the clients, which is what we call the categorization, where we are grouping the clients by different parameters, right? So you can see a distribution of the clients that are facing low data rate. So that's where you start. So AVA actually analyzes the clients to give you some more insight into like what might be causing these issues, right? So in some cases, it's not always easy to establish the correlation that poor app experience is caused by poor coverage. It can be multiple things. So in that case, we clearly say that we were able to find root causes for these many clients out of these many clients that were analyzed. Yeah,
I see. Okay.
yeah. Okay, so next step is recommendations. So once you have identified the root causes, there are like actionable recommendation that we suggest. For example, if there is poor coverage, we may suggest that you can increase the transmit power. If there are sticky clients, we may suggest that you can enable client steering. In other cases, you can suggest things like check if there are too many clients on the same channel, or you can even suggest turn on auto channel selection, right? So in fact, in this case, right, when we say there are too many clients with high uplink traffic, we even show the list of clients that are contending on that channel, so that we don't stop at just saying, okay, there are too many clients, go figure. Okay, so we also show you, okay, there are too many clients, and here is the list of clients that are contending, right? So you can see, okay, is there some client having a high upload traffic, which probably can be avoided, right? Or something anomalous that the clients are doing.
Is there a
Right,
way when, okay, you make these recommendations and I apply it, I'll take action on these recommendations. Is there a way to tell the system or tell Ava, like, okay, this action has been applied, now can we track whether or not this has a positive or negative reaction to that change, so that way you can either revert back or make another recommendation?
Yeah, so that's something we are working on. That's part of our vision of a self-healing network, where if you make a change, then you essentially tell Ava that please monitor it for me. Let me know after, like, or I don't know, 2 days, 3 days, or a week, how things are, right? And if things are not good, let me know, or you can revert it. So that's the first step, right? The next step is that this first step is important, where a human is making a change and asking Ava to monitor and get back with the results, right? So when Ava makes changes on its own in future, right, then the same logic still applies, right? So that's something we are working on as part of the self-healing network vision that we have.
Yeah, because I could see us maybe looking at the baseline, right? See in that point of time after I make the change, does that baseline get improve? But I think it's just like another step that we could try to move forward and automatically track things and let you know, like, all right, there was this root cause, there was a recommendation, and yes, that was a good action against that recommendation.
Right. Yeah.
Are you, for the recommendations, are you only looking at what you guys control in the cloud, or are you guys also giving recommendations on stuff you don't control? Let's say maybe you should add an AP, or maybe you should update the Wi-Fi drivers for that client, or maybe you should update the OS. You see what I mean? Do you only look at what you guys control, or do you go beyond that scope?
Yeah, so we don't get information about, like, specific information about client drivers and OS versions, right? That's not always available, right? But like talking about adding an access point, we do say that, like, if you know the issue that shows up is poor coverage and all the proper settings are already in place, right? Auto transmit power and all of that, like the system kind of goes through the config and sees, okay, whatever configuration should have been done is in place, and still clients are facing poor coverage, right? Then in that case, it may suggest that you need to probably add an access point to cover that coverage hole, right?
Okay.
So yeah. But like, you know, client specific information is not available to a Wi-Fi network unless you kind of put an agent on the client and it kind of sends back some information. So
yeah. Or unless we do the work ourselves, right? That's what we do today, right?
Yeah. So so yeah, I mean, there can be a set of recommendations that can be made. But yeah, I mean, like going back to your question, right? Like now that we come to this recommendation which says upgrade client cards or client drivers. So we do recognize that the client is not supporting the latest 2.4 gigahertz protocol, right? It's not an N client; it is still a B or a G or a BG client, right? Which is kind of taking more airtime. So we still recommend that maybe you want to, you know, upgrade the drivers, or if not, maybe not have this client in your network. In other cases, I mean, similarly, like if it's not supporting the latest 5 gigahertz protocol, right, you can suggest things like, you know, upgrade the client, right? So that's something that we do. Then there are other things that are kind of easier done, in sense that you can say that there are 5 gigahertz capable clients. So the network can know whether the client is capable of both the bands, and it can say it's actually operating in 2.4, right? Versus it should be operating in 5, right? And even things like there are no 5 gigahertz SSID available for 5 gigahertz capable client, right? So maybe you have turned off 5. I mean, this is very unlikely in today's world, but still, like, you know, it goes both ways, right? Is your configuration correct, and your configuration is correct, but the client is not making best use of the network, right? So we do make such recommendations. Yeah.
You're gonna have to update it with 6 gigahertz, right?
Yes. Yes, this is, I actually did update that, but not in this version. Yes.
No worries. You can, if you want to send us the updated version, we can put it in the show notes.
Yes. It looks very similar, actually. I mean, it's essentially because this is low data, these are root causes for low data rate. You just say that a 5 or 6 gigahertz capable client is operating in 2.4. It's unlikely that, you know, a client operating in 6 gigahertz is actually operating in a low data rate that's going to cause any issues, right, at a rate. It's mainly about 2.4. Yeah.
Now, when you make that recommendation that the client's operating on 2.4 versus 5, there's still other parameters that you're checking against, right? Because maybe 2.4 is actually operating well. Maybe it's the band is fine. There's no interference. There's no congestion. Or because I have seen systems that say, hey, there's clients on 2.4 when they're 5 gigahertz capable, but I've seen that there's no issue there.
Yeah, so I think the key point to remember here is that we are not going to this, we are not identifying this root cause directly. Only if a client is facing low data rate or poor app experience, that's when we start the investigation, right? So a client may be having great experience, which means it will not show these symptoms. We don't investigate, right?
Okay, got
so it. We just don't say that, okay, here is a list of clients that are 5 gigahertz capable but operating in 2.4, right? That's not useful. We say that only if that client is actually facing low data rate or poor app experience, and we start our investigation and we see that, okay, this might be an issue, right? Yeah. So how do you do this, right? So let me kind of summarize this a bit from like how you can use machine learning for root cause analysis. Now, there are like multiple ways. This is one of the way to do root cause analysis. So one is where you take the data, which is the observations that we saw, and also the domain knowledge and other inputs that we saw. You take that as an input where you have certain features and you have a target. then you train a decision tree model on that. So decision tree is nothing but like it's very intuitive in that sense, to understand where it actually what you get out of training on this data is essentially a tree which is intuitive to read. For example, it will say that if what the tree would learn is that if there is high retry rate and the client is operating into 0.4, then the client is affected. So that's the prediction a tree would make, right? So based on this data, that's what it has learned, right? And so on. Okay. So you train the tree, but you're not using it to predict anything. You're actually reading the tree to generate RCA statements, right? So in typical machine learning, what you do is you train a model, which can be a decision tree model, and then you use that model to predict on new data, right? We are not doing that here. We are training the model on existing data, what data is there, and then we are reading the rules that that model has learned from that data, right? What correlations it has learned. So you can see that a decision tree can also learn a combination of rules, not only like it will not just say that it's high retry rate, hence the issue. It's also learning a combination of rules that high retry rate together with operating into 0.4 gigahertz is likely why the clients are affected, right? So it's finding different combinations. In fact, like, that might together might be more impacting than individually, right? So that's the key, right? Like two things or three things together might have a greater impact than if you just look at them individually. You may not find something, but oh, okay, A, B, and C are happening together. That's when the client gets affected, right? So that's the rules that you derive from the decision tree once you train. So that's why we need both affected clients as well as non-affected clients, right?
Okay.
So
I think like machine learning is so mysterious to me. Like when you say train a decision tree model, are you like you let it make its decisions, and if it's incorrect, you tell it like, no, that's not the that's not the right conclusion you should have, and so you have it try to erase that from its memory. I don't know.
Yeah, so it's actually an intuitive process in the sense that it starts looking at the data, right? And it'll essentially at the first level, right? It'll split at properties that gives it maximum bang for the buck in some sense, right? So you can call it entropy, but the idea is that if you split, for example, on high retry rate, right? Like is that going to give you the maximum distribution of being able to judge whether client will face an issue or not, right? So at every step, when it splits, it decides what is the most likely parameter to cause an issue in some sense, right? So that's how it works. So it looks at the data and tries to come up with the best rules that describe that data, right? That describe that, okay, if these two things happen, then low data rate is likely to be true in your training. So it looks at what is in your features and what is the target, right? And what yeah.
Can I ask you this question then? With other companies that are using machine learning, and I just assume this is the same kind of machine learning everyone else is using, what sets that differentiator factor for you guys to anyone else with the machine learning?
Yeah, so it depends on like how you apply. So in some sense, if you look at machine learning, right, in 2022, right, a lot of it is kind of there are libraries, and a lot of it is kind of somewhat automated, right? So that's machine learning itself is not where the value comes in, right? How you use it, what data you provide as an input, how accurate your data is, right? That's where the value actually comes in, right? And there is this new trend in the industry which is sort of we can call it data driven AI, right? Where how can you improve the data using the same model to make better predictions? So you improve the data itself, not necessarily the model. Okay, so it's all about how accurate your data is, how much data you can put in, how much data you are capturing, right? So it's more about that than the part where you're training models, because these are now standardized procedures of training models and getting something out of them, right? So I think I mean, short answer is that for us it's the data, right? Like the data we are that's going as an input into this entire process. So I'm showing you a 3-step process. It's obviously a lot more complex than this, right? So, and I just showed you the observations, but I did talk about other inputs, right? So all of those go into different steps of this, and you get certain recommendations out. So it's also about stitching together everything into something that finally makes sense, right? So yeah, that's about ML for root cause analysis. Just a quick look into how it does that. So if you're doing root cause analysis for low data rate, here what we're looking at is a screen where Ava has come up with a report. What it's reporting it is, these are the top affected locations and the list of clients at each location, right? And it also giving you the top root causes across all locations, right? So some example of root causes are, there are 2.4 gigahertz only clients, or there is even a 2.4 gigahertz only network, right? So this is from an actual customer. So a network, and you can see they even have a 2.4 gigahertz only network, right? So that's a real thing. There is some high Wi-Fi interference, high contention. So there is all sorts of different issues in different locations, right? So it's AY summarizing that for you in like initial report. You can drill down into each of these locations. You can look at each location, what's happening at that location. So for example, at one of the locations, it's saying that 32 clients are facing the issue because it's a 2.4 gigahertz only network, right? Now, at the end of the day, you are probably fine with that. That's up to the network engineer to decide, but it has figured this out, that there are clients that are not getting appropriate data rate, and essentially it's a 2.4 gigahertz only network, right?
Could you tell this could you tell the system it's okay? Because like for some of my customers, we've deployed I call them single band SSIDs, like different SSID names for 2.4 versus 5 gigahertz. So would would Eva see that as a 2.4 only network and flag it?
So this is yeah. So in a given SSID, right, in a given network, you can enable that on either 2.45, both or only on one, right? So you can select like what bands you want to run that network on, right? So here it's actually saying that that the network, the SSID to which these clients are connecting, they are 2.4 only.
Okay.
Right. Yeah.
Okay.
So yeah, I mean, like if you set up SSIDs which have separate names and they are essentially running, like obviously it'll essentially just call out that network, right?
And
now,
Ron, if I'm not mistaken, we have a video that we're going to link to that actually shows this workflow in Ava in action.
Yes.
Later.
Yes.
Yeah.
Yes. So there is a video. I'm just giving a trailer here of what it looks like. Yes.
You're teasing, so people go watch the video.
Yes. Then the second statement, so I'm not showing all the statements. So the second statement says that there is high contention because of too many BSSIDs, and there are 13 clients at a location that are facing issue because of this. Now the interesting thing here is that you see a list of 13 clients that are impacted by due to high contention, and against each client we are also showing how many client contending access points are there on that channel, right? So on channel 1 they have 11 or 10 contending access points, right? So you can actually click on that and see which access points.
Now, is that also your access points and also another neighbor's access point?
No, these are so I'm not sure. I think these
all access points, right?
Yeah, these will be all access. Yeah, these will be all access points.
Be a nice way to tell someone like you got too much co-channel contention as well.
Right. Yes. So that's the other statement. Now, just a brief look at the recommendation. What for high contention, what it's saying is that in radio settings, set transmit power selection to auto and enable dynamic channel selection at this location. And also it is suggesting that make sure background scanning is on. So it is giving you very actionable recommendation that this is what you need to turn on. And it has seen that these things are not turned on, so you can go and turn them on. Otherwise, this recommendation wouldn't have been made. And it is even telling you which location you need to do that, right? So, it's very actionable for the network engineer, right?
Yeah, and it's a clear recommendation. There's nothing mysterious about what I need to do in order to do make that change. So
Right.
I think for a lot of people to actually not even a lot of people, but like the whole auto channel thing, the whole dynamic channel selection, that's where I start trying to make sure it's doing the right channel selection. I've seen systems that just kind of stay stuck on, puts all the APs on a single channel until a given interval, because maybe that interval then runs at a time when nobody's around. So channel 36 always looks good. So therefore all APs are on channel 36.
Right.
For your dynamic channel selection, I think this goes back to our previous comments where when you make this change, will I see that baseline be positive or negative after the change?
Yeah, so right now, if you make that change, you can obviously observe the baseline. AVA doesn't do that for you today, right? But yeah, you can see on the baseline if things have improved or not.
Cool. It's looking good.
Well, that root cause for that device, for those set of devices, will go away if
Right.
it was effective. If not, it'll still exist. Yeah.
Got it. Okay.
Right. So that was about like we covered client experience from connectivity, performance, right? The last but the most challenging one is app experience, right? And like so in this part, like your client is using some application. It can be a cloud application, it can be an intranet application. The client or the user who is using the application knows whether they are getting great experience or not. But the real question is, can your network know, right? So the first breakthrough we had in this space was in 2018, that's where I presented at WLPC, right? This is where we presented this first back in 2018, like how you can measure application quality of experience for conferencing applications. That's how we started. And just to summarize, what we are doing is you cannot obviously look into encrypted data for conferencing applications, but you can look at the network data, right? So what we ended up doing was we looked at network data, extracted certain features like bit rate, packet rate, and so on. And we essentially did that offline in our lab, where we collected a lot of data for good calls and bad calls. And then we trained a model, a classification model, like support vector machine model, which actually to which we told that, okay, these set of records correspond to good calls, these set of records correspond to bad calls. And we trained the model to say that, okay, if you see this, essentially what the model eventually ends up doing is that it looks at network data, new network data, and predicts whether this call is likely to be good or bad, right? Like this 30-second segment of the call is good or bad, right? So that's what it does. And that's when we had like that's when we first introduced application quality of experience in the Wi-Fi domain for conferencing applications. So this is still there. So there cannot be a better use case, right? Today, when everything is online, it's all, video conferencing. Yeah.
Which segment of the network are you looking at? Are you just looking at the Wi-Fi segment, or are you looking at, the Wi-Fi plus the LAN plus the WAN? Like, where do you stop to be able to train that model to say if it's good or bad?
Yeah, so we are capturing like essentially all data is going through the access point, right? So this data like essentially is being captured, like you're essentially looking at the UDP flows, right? So most conferencing applications would run on UDP. In some cases, they will fall back to TCP. So what we are doing is we are looking at the UDP flow, right?
Okay.
And from there we take out the bit rate of that flow and the packet rate and so on, right?
So that's once the traffic has been over the Wi-Fi and then decrypted by the access points right before it goes into the LAN. That's where you look at the data, right?
Right. So we cannot decrypt it. So it's a UDP flow. So we are really looking at UDP frames, right? So we are not at layer 2, right? So we are looking at UDP frames, and we are not decrypting it. We are just as the data. Yeah. Okay. So we are looking at data in both the directions, incoming call data and outgoing call data. We look at both of them separately, right? And for each, we are looking at bit rate, packet rate, and for each segment, incoming or outgoing, we are predicting whether the call is good or bad. I think that was your question, right? Like which segment?
Yeah, exactly. Yeah, I was just curious to see, like, to be able to use that model, do you just need Arista APs, or do you need to deploy, Arista switches with it, or the whole stack, so you guys can have enough data to do this? But it sounds like you guys can do this just with Arista APs.
Yes, you can do this just with Arista APs. Yes.
Yeah, so just as the data comes onto that LAN port of the AP. So even before it goes over the air, you're looking at this data.
Yes, and we are looking at on the other side as well. Like before it goes on to the LAN port, we look at that. Right. So it's a bidirectional flow, right? When you're making a call.
So you are able to identify that it's like a Skype, a Zoom, or Teams, or whatever.
Yes, we are able to. Yes.
Okay.
So we on the application dashboard, we have a tile for each application, and you can monitor up to 25 applications as of today.
Nice.
So you can select the applications that you want to monitor, right? Like so it can be a mix of conferencing apps or web apps. So we'll talk about web apps. So this was back in 2018, but we had another breakthrough recently. So we'll talk about that also. But anyway, like this is the rough flow where a machine learning model is. So this part is in Arista Cloud, of course. The machine learning part and prediction part, all of that is happening in the cloud. The access point is just extracting the features and sending it back to the cloud, and the model actually sits in the cloud, right?
Okay.
Right. And then finally, you get something like this, right? You get a tile like this, which says that this is how the app experience is, and what percentage of time the app experience was not great.
That must have been fun to test in the lab.
Yeah, we continue to test that. I mean, it's interesting to look at. And in this case, we are also able to say whether it's a wired issue or a wireless issue. Actually, going back to your previous question. So if we see issues in the incoming, like from switch to AP traffic, if we see issues in that, then we say it's likely a wired issue. If we see issue more on the uplink, then we say it's a wireless issue likely. Okay. So how did we extend it? So now, like as of today, so back in 2018 when we introduced, you could monitor only conferencing applications, and now as of today you can monitor web applications also. Okay, so any web application like your Google Workspace, Office 365, anything like that an enterprise might use, right? And we also allow people to configure their own application as long as it's running on TCP. Okay, so how did we extend that quickly, right? So we actually captured a ton of web traffic within our network to see how people use applications, and like what should we do for web applications. We captured a ton of packet traces, and we did a lot of analysis, a lot of data science, exploratory data analysis went into this. Took us a lot of time, and I mean, this is an obvious assessment. Like if you have packet retransmissions, that's when the applications are affected the most. Like when we say packet retransmissions, we mean at the TCP level. Okay. So we this is what we realized, which was like in the hindsight obvious, but we wanted to validate that with the data. And then in AVA, what we built was additionally was the ability to detect packet retransmission events. So this is happening on the access point where the AVA engine sits. So AVA is at different places in our solution. Sometimes it's also on the access points. It's parts of it are also in the cloud, right? So we gave it the ability to detect packet retransmission events. So if there is an open TCP connection, we can detect if a packet is being retransmitted on that. And we are then able to compute the wait time due to the packet loss. So so you lose a packet due to whatever reason, right? Either in the uplink or in the downlink. Now, because TCP is a reliable protocol, it will try to send that again, right? So the application is going to wait for that packet, and how much time did the application lose before it actually got that packet is the time that's impacting the application. That's when it's not getting great experience, right? So it can be in like microseconds, milliseconds, right? But that's what matters, like how much time it has to wait. So what we ended up building was flow level monitoring in the access point, and what it ends up doing is how much time it took for the application to recover across all the flows for that application. Okay, so what I'm trying to say here is, for the applications that you select, you want to monitor, we are monitoring every TCP connection that's going through the access point, and then we are able to judge how much time was lost in retransmission of frames, like how much time was lost in recovering from the packet losses, right? So when you sum that up, you get a good idea. Okay, out of this total usage time, this is how much time you lost in recovering, and that kind of determines your application experience at the end. And
A lot
all
of
of this
processing for an AP to continually look at all this traffic. Is there any impact to the actual performance of the AP and the clients it's serving?
That's a very good question. That's something that does come up. So we optimized our algorithm to an extent that the throughput impact before and after this feature was not more than 1 to 3%. Right. So if you turn this on, so there is an option for people to turn this on. This is on by default, but you can turn it off if you want, but it's not required. So if you turn this on, the throughput impact is not very noticeable, right? So that's how optimized the algo is on the access point. We knew this, like that's why we also have this limit of monitoring 25 applications, not more than that. Yet we may increase it later, but I think 25 is good enough for some
25 applications, you could see up to like 3% of the throughput impact there.
Yes.
Okay.
Yeah. So yeah, just to give you some architecture overview, right? So you are detecting which app it is first. That's the key, right? And AVA is sitting on the AP, and then AVA is actually deriving these two metrics. What was the idle time, like when the app was not being used, and what is the recovery time? It sends that data to the cloud, to NetDB, and from there we essentially do aggregation and all, and we are able to show a dashboard like this, where for each application you can say how much it is impacted, right? And we do have a video later which shows you this in action, like this whole app queue in action.
So what would be the accuracy of this? Like if you compare what AVA is giving you to the real user experience, like how often would you say that AVA is giving you the good information?
Yeah, so we sort of tested it in our network, in our lab, and we found it to be fairly accurate. Like if there was an experience, then we saw that it did show up like that. And by the way, the bad experience can be due to multiple reasons. Only a specific client might be facing an issue, or entire app might be facing an issue. So you can drill down and see that. Like if you see a bad experience, like some Evernote application is not getting great experience, right? You drill down and you can see if all clients are impacted or a few clients are impacted, right? Then it might be a client only issue, or it might be like, holistic app level issue as well.
When Facebook went down the other day, did you guys notice it?
Yeah, I think we did. I remember some cases, but not many enterprises monitor Facebook, right? So
yeah, or WhatsApp, I guess it would be more
Yeah.
useful.
Probably more of the video like Zoom or Skype is
Yeah,
what they're
yeah,
looking at.
yeah.
okay, I think so. That's it. I think from a client experience perspective, right? What's important is why it's happening and what you can do to fix that, right? That is how we would define network assurance, right? That's what it matters.
Mm-hmm.
And if I could, I know we ran over a little bit here, but if I could just get maybe 5 minutes to just show you what does it mean in terms of the UI, right? How do we help? And
yeah, I think that would be useful.
Administrator, if I could share my
Yeah. Thanks.
For sure. Yeah, I think it's really nice to see that you guys focus on the user experience, because as a Wi-Fi engineer, that's what I try to do always when I work, whatever the work I do, design or troubleshooting. Like I always say we don't design Wi-Fi networks for us, we do it for the users, right? And so what matters is the actual user experience. If they're having bad user experience, it doesn't you didn't do your job properly, pretty much. So it's nice that you guys have that as well as the part of what you're doing to kind of measure, how the network is doing.
All right. So let me just kind of pick up where Karan left off in terms of showing you some of these dashboards. So the way I like to think about network assurance is like two parts. And I remember when we were thinking about implementing network assurance back in 2015, at Mojo, in the Mojo days, we were debating, should we just do passive or active, right? So passive, we're not injecting any traffic. We're not exercising the network using simulated clients. We're just observing, right? And so I guess the way we settled is we're going to do both. We're going to do passive and active. And so the dashboards that we were covering here, so the connectivity dashboard, right? So we're just looking at like Karan says, the more deterministic. And so we see here, anytime there's a connection failure, we're going to tell you why the connection failed, at what stage, and we're going to do a packet capture so that you can later on go open that up and look at, packet capture and either download it or open it up in packets to get that graphical visual representation of the conversation between the client and the AP. But, most of the time you don't have to do that because it's going to just tell you which clients are having issues. Right. So this is all passive. We're not exercising it. We're just observing and we're telling you where it failed. That's client journey. You can go back to 1 month here in the cloud. If you do an on-prem, that would be 1 week for on-prem, because we want to make the point that we support both cloud-based management appliance, management or on-prem, either a VM or a hardware appliance. And so you have that choice, but you're going to get a less time covered if you do the on-prem. All right, now performance dashboard here. Again, you can go back to 1 month in your dashboard to see what's going on there in your baselines. And you can see here, if I hover over, I can see there get a little bit more information there. If I were to click on that, retry, I can see the clients and I can sort on the retry rate if I want to see the clients with the highest retry rates or the lowest retry rates that were called out here. And if I click on a client, then we can ask it to do root cause analysis and it may come up with, root causes. And in this case, we have a number of them: high contention BSSID, high Wi-Fi interference, and poor coverage. You can click here on this one, for instance, and it can tell you, okay, first of all, you don't have auto transmit power enabled, so do enable that. That's the recommendation. But then it also recommends potentially adding more access points because, this may not solve the issue. So you're getting some recommendations there that seem reasonable.
So the root cause analysis is done as soon as you click on the client?
Yes, yeah, it's real
Okay.
time, right? The
Okay.
root cause analysis is done real time though. So here we have a sticky client. Let's see if it finds anything.
Okay, I can see.
haven't
Yeah,
tried this
root cause in progress.
Yeah, root cause in progress. So,
Okay.
and you know, what's really interesting about the sticky client one, this one doesn't show up too often. It's a rarity in this demo network that we have. So that's
Which is special, Robert.
No,
yeah, it's special. It's very rare. And now if we move on to, I know I'm going fast here.
Yeah, I just have one question, Robert. When you do click on that client and it does the root cause analysis, does that client have to be on the network?
Yes, this is real time.
Okay.
This is not historical. For
So if the client,
yeah.
So when it does show you the list of clients, that's just all clients that are actually on the network.
Yeah, that are on the network that are having issues currently.
Got it.
Yeah. Yeah. And so yeah, exactly. And so to get historical, what happened in the past, you'd have to go use your baseline and then go back that way. Well, that's one way. Or you can go to a particular client and go back and look at the history for that client. And I should point out also that we don't just keep track of performance of clients, right? And the network in the area that these clients are associated to. That's a part of it all, of course. But also network services. So we look at AAA, network performance, availability, DNS, DHCP, et cetera. And it's all location specific. So you can see these values change if I go up to the hierarchy. So as I go to the top, now we're looking at the whole organization. But if I go down to a building, a location in New York, you can see how this is location aware there. So again, all passive, still we're not exercising the network. And then we go into the application quality of experience or web QoE dashboard. And like what Karan was saying, I can customize this. I can select the applications that I want to see in my dashboard. I can even select a custom application for TCP based applications here by just giving the host name or the IP address and the port it's using. So I can start monitoring those and reporting quality of experience for those as well, using TCP, KPIs. Now for real-time applications, that's where we use that support vector model to train the machine. And for here we have, we can see that GoToMeeting. There are a number of clients that are experiencing issues with GoToMeeting. I can scroll down and I can look at, the relative, the quality of experience for them. And so on. And I can get some information about, the OS, but not as much as we'd like because we don't have an agent on the client. I should mention, I'll show you what we can do in terms of like client categorizing the type of clients that are having an issue. And then I can scroll down here and I think it was one that I found earlier that was pretty interesting. I can click on it. Nicholas Beverly. Let me see. Go back up. This is, let's see, I'm going to go to one. I found one that it had an interesting, it was showing our, I think it may be this one. Let me see if it's this one. And where we were showing the root cause of where we had some code channel interference. Oh, I stopped talking because my CPU and my computer is giving me some issues right now. Apologies. Okay, low RSSI, not exactly the one I was looking for. I was looking for one with where we had high channel contention, because that's a cool, interesting example. Because if it finds that there's high channel contention, it'll tell you the APs in the area that you're contending with. And I thought that was a pretty cool one to show, but now that's not an issue anymore. All right, so those are all the that's all the passive part, right? Those three dashboards, and the part of the passive part of our assurance. Now I'm going to move on to the assurance, which I'm going to move on to the assurance in terms of cognitive mapping. It's all, again, this is passive as well, cognitive mapping. And I had to minimize the screen a little bit there, apologies, but there seems to be a problem with Zoom right now and my CPU. So this is something we talked about in the episode, right, of this series, and we call it cognitive mapping. And that's where you can look at a floor plan, look at where your APs are placed, and then you can highlight the clients that are having issues, connectivity issues or performance issues, like low data rate, low RSI, where you can identify maybe perhaps where you have coverage holes, et cetera. And if you click on that, then you'll be able to see where, like right now, I've clicked on clients that are having authentication failures, and then the machine's going to tell me, where those clients are that are having issues. So it helps correlate to different types of issues with locations. So that's helpful. So that's all passive, right? We're not doing anything. Now let's get to the active part of, or proactive part of network assurance. And we call this a client connectivity test. It's not really the best name for a feature because it's doing way more than client connectivity test. What it's actually doing is we're going to be taking that multifunction radio that we have on most of our platforms. There's very few that have a multifunction radio. So we take that multifunction radio, and one of the things that we can do with that radio is instantiate a virtual client on it, and then do a series of tests, not just a client connectivity test, but we're going to do all kinds of tests, and we'll take a look at some of the things you can do there. Let me see. I think I recovered. I'm going to gamble here, see if I can go full screen again. All right, so here you can see you can select the SSID, the frequency that you want to test, and you can test your your portal, whether it's if you have one, you can test PSK or AAA, so you can test your radius server, etc. Then you can select the applications that you want to test, and we don't just ping these applications, we're actually going to do page polls and report latency as well as availability. And then you can do a simulated VoIP test over the air. And you can do throughput tests on the internet and Wi-Fi. And so it's pretty comprehensive, right? It's a virtual client to cloud. And so we're really exercising the network from end to end. And so you can get an idea if there's an issue along the way. We can schedule those tests, right, to run every day before the bulk of the workforce comes in, or before the student body arrives, et cetera. Or you can schedule a test, like I like to use the example, if you get reports of VoIP performance in a particular part of the network at a particular time of the day, then you can schedule VoIP tests for that part of the network to do some trend analysis. It's not using the handsets, so you're not getting that level of testing. But at least it's another view. You can ferret out issues of capacity and high latency or high retry rate is the reason for VoIP issues in that part of the network at that time of the day. And then let's take a look at some results. If you have a failure, and here we have orange, which indicates something went wrong, we can then have alerts set up to send to the network administrator. So quickly, you're looking at the access point here under test, right? And then you're looking at the access point that is doing the testing. So that's where that virtual client is instantiated in the multifunction radio. We're showing you the band that's tested and the test that is running that we created. We look at association status, authentication status. In this case, it was simply PSK, could have been AAA. We look at DHCP, the address of the server and the latency of the server, DNS, the address of the DNS, and the gateway. Then we look at the gateway latency here, reporting it back at 2 milliseconds. The DNS latency here, the address, as well as the latency of 23 milliseconds. Then WAN latency reported as 8 milliseconds. And now on the application test, we can take a look at the applications. We have productivity applications selected, Office 365, Box, Google Drive, Zendesk, and Salesforce. And we see we have a failure here at Salesforce. So now we could have had an alert sent to the people that are responsible for managing this part of the network, so they get the heads up, so they can then send out a notification proactively to the workforce saying, hey, we know we're having an issue with Salesforce and we're working on it. And you can send that out before people even show up into the office. And again, we don't just ping the applications, but we're doing a DNS reporting, DNS lookup time, initial connection time, and SSL connection time, and page loading time. So you get that kind of performance to some extent, of the service that you're in testing. And we show we have, for social, and then also for communication, Skype for GoToMeeting, Slack, etc. And customize, you can add your own IP addresses or host name, and they can be wherever. They can be, private cloud or on-prem, etc. And then VoIP, we're going to report a MOS, and this is VoIP over the air. And here we see that in this case, it's for 0.39, and give it a star rating of a little bit over 4 out of 5 stars, and so on. And then we have throughput, chest, internet, and then Wi-Fi. So I know that was a lot, but so that's the active part of the, or proactive part of network assurance. So together with those dashboards, the connectivity dashboard, the performance dashboard, the application quality of experience, web quality experience, the cognitive mapping, et cetera, that's the passive. And here we have the proactive. Together, you give your, the people responsible for managing the networks a really good idea of the health of your network and the availability and the performance of your network.
There's no additional hardware required.
That's right. Yeah. We don't have to. You don't have to buy sensors, additional sensors. It's just built in, and that multifunction radio does a lot of things, right? It doesn't just act as a client, right? It's doing WIPs, over-the-ear detection and over-the-ear prevention, spectrum analysis, and high fidelity RRM, scanning, because it can get through the channels faster. It doesn't have to go do the scanning and background scanning. So yeah, it's all built in.
It's a useful tool for someone who maybe has to troubleshoot remotely, and you don't have someone you could do the test for, right? Do the test for you, so you can run your own test and be able to see where the failure is happening.
Yeah, that's right. All you need is two. You need 2 or more APs, right? Because you need an AP acting as the client, AP acting as the the AP under test.
Does this work on all APs or specific APs?
The AP, there's only one AP. If you look at our Wi-Fi 6 APs, the only one that doesn't have a multifunction radio is the C200. And so that's just a 2.4 and a 5 gig radio. But all the other Wi-Fi 6 APs have the multifunction radio, so they can all do this. They can all do client connectivity tests. And the new C360, which is our Wi-Fi 6 AP, it has 4 Wi-Fi radios, a 2.4, a 5 gig, a 5 gig plus 6 gig. So you can do dual 5 gig until you have enough 6 gig clients, or until you have that 6 gig spectrum opened up in your region. And then it has a multifunction radio, which is 2.4, 5 gig, and 6 gig. And so, yeah, pretty much, I mean, there will be some, chances are there will be some lower down market, if you will, APs that don't have the multifunction radio, because it does add a little bit of cost. And so, but most of our APs will have this multifunction radio, the vast majority of them, to support this type of testing. Okay. Yep. And by the way, I wanted to get your input. So you saw what we can test, but what additional tests do you think we should add to client connectivity tests? Can you think of any?
I'd like to do like a capacity test.
A capacity test.
Yeah.
Yeah.
You'd have to have enough access points in the area.
like instantiating multiple virtual clients, because you can put 128 or whatever, 250.
Yeah, I mean, here's a common request that I hear on a campus. They'll say, hey, we're gonna have this event on Thursday and there's gonna be 300 people. Can this work on the Wi-Fi network?
So you could test your captive portal that way, or you could test your whatever, your NAC that way, right? And your radius server, etc. You could, if I could instantiate, instead of one virtual client, I instantiate, 256. And so you're not doing over the air capacity in terms of like network performance over the air, because these are all virtual clients, so you're not going to get the same type of contention, etc. But just to test your service, your radius service, right, or your portal, and can it handle all that additional load? I think that's a good one. Karan, when are we going to have that?
Soon enough.
It'll happen, right? I can ask for it.
Yes.
But when does your 6 gigahertz AP come out? Is it already?
It's orderable now, and we're looking at it's next quarter. It'll be FCS next quarter.
Okay, and all the features that you guys just showed in this episode, that's available for 6 gigahertz APs.
That's right. Yep, that's right. All 6. Yes, we'll be doing. And by the way, it also does packet capture, so we'll be able to do packet captures on that multifunction radio 6 gigahertz as well. So the AP support inline packet capture or using that multifunction radio, which is kind of like having a discrete sniffer, or your.
So speaking of packet captures, then I would like to see how well like Wi-Fi 6 is actually working with the whole OFDMA, the RU.
Right. Well,
the
I did
efficiency
a lot of,
there.
going off track here a little bit, but I did a ton of competitive OFDMA MU MIMO efficacy
MU
testing.
MIMO, okay,
And both, right? So I got a bunch of Wi-Fi 6 clients in house, and I got a bunch of competitors' APs in house. And you may notice that let me just give you a hint. Have you seen any competitors? I mean, I know Roel, you did a set of tests with the one competitor, but there's been there hasn't been many competitors coming out with all these, look at how wonderful OFDMA is working,
you can't see it.
Yeah, it's hard. It's really been a challenge so far.
So maybe we'll talk offline about that, Robert, and maybe we'll turn that into another episode.
Yeah, we can do that. But I would just say that we do see some benefits of aggregate throughput with the MU MIMO, as you'd expect. And we do see some benefits for sure with OFDMA in terms of reducing latency. So there are benefits. It's just that it's been hard to quantify sometimes and demonstrate, et cetera. But we're all working on that, right? We're making improvements. And I say we, including the chip vendors, right, for the radios that we're using. So.
Cool. Well, I mean, this was a lot to unpack here on this episode. I think it's a lot of great information, and a lot of things that we're seeing is what people want on their networks, right? Whatever you just showed us with the whole network assurance, the client journey, troubleshooting, even this testing, knowing that your Wi-Fi network is working properly. I think that's everything that people want in their Wi-Fi network, right? And I give you guys a lot of kudos for diving into how your model is done, the kind of decisions you're making, and the data that you're ingesting there into the model. I think that's really good information for us to understand about whether or not we should trust this data. Because I know a lot of vendors just say, "Hey, this is the latest and greatest. This is how it works. We're going to do this and give you this information," but they don't really go into the details of how that data is collected and how it's processed.
Well, thanks for that feedback. Yeah, that's where Karan comes in, because he knows it's when I present, it's much more higher level. But Karan, having built it, he knows exactly how it works. So, yeah, thank you for that feedback.
I think in the next evolution of AI-based solutions, I think trust will be a big factor. That's where we are getting to, right? Especially. If you look at AI in general across industries, right, I think trust is something that people are looking for, and explainable AI is kind of gaining a lot of traction in recent years. So I think that's what our goal is also, that whatever we do is explainable at the end.
I want to thank you guys for joining us here on this episode. Where can people reach out to you and learn more about Arista Networks and Wi-Fi?
Let's see. Well, you can go to our website, but as far as for me, I'm available if people want to reach me. You can reach me at directly RF at Arista if people have questions. I'd be happy to answer them, and that's probably a good way to start. And then also Medka is we shared her email address last time. She's available as well. So you can reach out to both of us. Karan, I think we want to let Karan stay a little bit in the background because he's super busy developing new feature functionality. So
got to work on it.
Yeah.
Improve it. Keep working that model, right?
Yeah.
All right, cool. Francois, you want anything to add before we end the episode?
No, I really enjoyed it. I know that was a lot of information, but no, I thank you guys for coming in. I know it's late for you, Karan, so we'll let you go to bed. But yeah, it was really, I was into it. It was really good. Thank you.
Yeah, thank you guys. We'll include some more resources on the show notes. So if you head over to cleardesign.net, we'll have all the episodes. There's one more to come. So we'll have a list of episodes there from Arista if you want to learn more. But we want to thank you guys for joining us. And if you have any questions, leave a comment, hit up our YouTube channel to see the video as well. But we want to thank you guys for listening. Bye, guys.
Thanks again. Bye now.
Thanks. Bye.